Hi everyone, welcome back to my channel Criminology and Forensic Science. I want you to imagine a crime scene where there are no fingerprints on the door, no obvious weapon, and no eyewitness who can clearly identify the suspect. At first glance, it might look like the scene has given investigators almost nothing, but what if the real evidence is hiding in something so tiny that you could easily brush it away without even noticing? A microscopic fragment of glass, a tiny piece of plastic, a few grains of unusual soil, a pollen grain trapped in a shoe thread, a fragment of wood transferred onto clothing, or even a minute particle of cosmetic material. These tiny materials may look insignificant to us, but to a forensic scientist, they can become pieces of a much larger investigative puzzle. And this brings us to one of the most fascinating areas of forensic science, trace evidence. So in today's UGC Net Forensic Science series, we are going to understand what trace evidence actually means, how Locard's exchange principle explains its existence beautifully. We will look at some interesting real-world applications and most importantly understand why these tiny clues can matter so much in an investigation. So let's begin with the basic definition. Trace evidence refers broadly to small quantities of material that can be transferred between people, objects, or environments, often during contact. The important word here is transfer. Trace evidence is generally associated with materials that may be very small, sometimes microscopic, and may be easily overlooked during a crime scene examination. Common categories include fibers, hair, glass, paint, plastics, soil, minerals, botanical materials, gunshot residue, wood fragments, cosmetics, and other small transferred material. But here is an important point for your UGC NET preparation. Trace evidence is not defined simply by being small. Its forensic importance comes from the fact that the material can provide information about contact, association, movement, or its possible origin. Think about it this way. Suppose an investigator finds a tiny fragment of an unusual blue plastic near a damaged object at a crime scene. That fragment by itself may tell us very little, but investigators may compare its physical and chemical characteristics with a known plastic object recovered from a suspect's vehicle or possession. If the characteristics are consistent, the fragment may provide an association worth considering along with all the other evidence. Therefore, trace evidence is often about connecting things that initially appear unrelated. Trace evidence is fascinating because it often represents something that happened without the person even realizing it had happened. A person doesn't have to deliberately leave evidence behind. They may simply walk through an environment, touch an object, sit somewhere, brush against a surface, enter a vehicle, or move through vegetation. During these ordinary physical interactions, tiny materials can be transferred. The investigator's job is then to recognize that apparently insignificant material, collect it properly, examine it, and determine what information it can provide. This is why trace evidence is sometimes described as a silent witness. It doesn't give a verbal statement. It doesn't tell investigators, I came from this person. Instead, its characteristics must be scientifically examined and interpreted. And this leads us directly to one of the foundational concepts of forensic science. Now, if you are preparing for UGC NET, you absolutely need to remember this principle. That is Edmond Locard's exchange principle. It is commonly summarized as every contact leaves a trace. The basic idea is that when two objects or surfaces come into contact, material may be exchanged between them. In forensic investigation, this can result in material being transferred from a person to an environment, from an environment to a person, or between two objects. In simple words, you leave something behind and you may take something with you. That's the beauty of this principle. Just imagine someone walking through a particular environment. Something from that environment may become attached to the person's shoes, clothing, belongings, or vehicle. At the same time, material from the person may be deposited into that environment. So the exchange can work in both directions. This is why it is often called the principle of mutual exchange. Let's make this extremely easy to remember. Imagine two surfaces, person and the environment. The person enters the environment, the person may leave behind material. At the same time, the environment may transfer material onto the person. So we can think of it as person, environment and person. That two-way transfer is extremely important. For example, just imagine a person walking through a garden containing a particular type of flowering plant. Tiny pollen grains may become attached to the person's footwear. At the same time, particles from person's shoes may be deposited along the path. Now imagine investigators later finding unusual pollen grains in the thread of footwear. The pollen does not automatically prove that the person committed a crime, but it may provide an association between the footwear and a particular environment, especially if the botanical material has distinctive characteristics and the circumstances support that interpretation. That is Locard's principle in action. Let's take a more interesting example. Now, suppose investigators are trying to determine whether a particular individual may have recently passed through a specific location. There are no obvious fingerprints, but microscopic botanical material is recovered from the person's footwear. When examined, some of the particles are identified as pollen. Now, pollen is everywhere in the environment, so finding pollen alone doesn't automatically establish a unique location. But suppose the investigators are dealing with a particular combination of pollen types that is consistent with vegetation present at a specific location. That information can become useful as part of overall investigation. This illustrates an important forensic principle. Trace evidence often gains strength from context and comparison. The question is not simply did we find pollen? The better question is what does this pollen tells us and how does it compare with material from the relevant location? Now let's take another example. Imagine a damaged wooden structure at a crime scene. During examination, investigators recover a few extremely small wood fragments from an object associated with the investigation. At first, they might look completely insignificant, but wood can have characteristics that allow forensic scientists to examine and compare it. The scientist may consider features such as the type and microscopic characteristics of the wood depending on the nature of the examination. If a fragment from an unknown source shows characteristics consistent with the known wooden object, that may help investigators evaluate whether an association exists. Again, the fragment is not magically saying I came from that exact object. Instead, forensic science asks, are the characteristics of these materials consistent with one another? That distinction is extremely important in forensic interpretation. One more example that is often overlooked when people think about trace evidence is just imagine two surfaces coming into contact during an investigation. A small amount of cosmetic material is recovered from one surface. It could potentially contain pigments, oils, polymers, or other components. Depending on the material, forensic examination may be able to characterize and compare it. Now imagine that a similar cosmetic material is recovered from another relevant source. Again, the forensic scientist does not simply declare this came from that exact person. Instead, the material is examined scientifically to determine what characteristics it possesses and whether those characteristics are consistent with the known sample. This is an excellent example of why trace evidence requires scientific comparison rather than just assumption. Now let's move into a classic forensic scenario, but with a slightly different angle. Imagine a vehicle collides with an object and leaves the scene. Investigators later recover a tiny fragment of plastic from the damaged area. That fragment could potentially originate from a vehicle component. Depending on the material, forensic scientists can examine characteristics such as its physical appearance and chemical composition and compare it with a known sample. Vehicle-related investigation can involve trace materials such as paint, plastics, glass, and other fragments. This can become particularly valuable when investigators don't have a complete object to work with. Sometimes the crime scene doesn't give investigators a whole piece of evidence, it gives them just a fragment. And forensic science tries to extract as much information as possible from that fragment. Now let's take the concept one step further. Not every trace necessarily moves directly from its original source to the final location where investigators find it. Imagine source, person, and object. A material may first transfer from a source to a person and later from that person to another object. This is sometimes discussed in terms of secondary or subsequent transfer. Why is this important? Because finding a trace material on someone does not automatically mean that person directly interacted with the original source. There may have been an intermediate transfer. This is one reason forensic scientists must be cautious when interpreting trace evidence. The presence of a material can be meaningful, but investigators must always consider how the material could have arrived there. This is one of the most important concepts for UGC net. Suppose a forensic scientist finds a fiber on an object. Can the scientist automatically say this fiber came from this exact sweater? Not necessarily. Many trace materials are manufactured in larger quantities. For example, numerous clothing fibers may share similar characteristics. Therefore, a trace comparison may demonstrate an association or consistency, but it may not necessarily establish a unique source. For example, forensic labs note that comparisons involving fibers and other mass-produced materials can be highly useful for demonstrating associations, while absolute source attribution may not be possible in many circumstances. So remember this distinction: association is not equal to automatic individualization. That single distinction can save you from making a tricky mistake in an examination. Now you may be wondering, if these materials are so tiny, how can forensic scientists actually examine them? This is where laboratory science becomes extremely important. Depending on the material, forensic scientists may use microscopy and a range of analytical techniques. For example, trace evidence laboratories may use microscopy, spectroscopy, elemental analysis, and other instrumental methods for materials such as fibers, glass, paint, and plastics. For glass, scientists may examine characteristics such as color, thickness, type, refractive index, and elemental composition. For paint, examinations can involve microscopic and chemical characterization. So the trace evidence lab is essentially asking, what is this material? What are its characteristics? What known samples can it be compared with? Are the characteristics consistent? And finally, what conclusion can scientifically be supported? Now let's answer the biggest question: why does trace evidence matter? Because it can help establish relationship. It can potentially connect the person and the crime scene, the person and the object, or the object and the object, or person and the environment. It can also help investigators reconstruct what may have happened. Forensic evidence can sometimes provide information that helps establish associations and reconstruct events, and physical evidence may corroborate or challenge accounts provided by witnesses or other sources. Just think a case where two different stories are being presented. One person says, I was never there. Another says, I never touched that object. Now imagine investigators recover a collection of trace materials that are scientifically consistent with contact between the person, the object, and the relevant environment. That doesn't mean one tiny particle solves the entire case, but collectively, properly interpreted trace evidence can become another piece of the investigative puzzle. This is perhaps the most important message of today's lesson. A single trace may be weak, but investigations rarely depend on just one clue. Imagine investigators recover a particular type of plastic fragment, unusual botanical material, a distinctive coating fragment, and microscopic environmental debris. Each individual finding may have limitations, but when these findings are properly analyzed and considered alongside other evidence, they may contribute to a much stronger reconstruction of events. This is why forensic science is not about finding one magical piece of evidence. It is about collecting, analyzing, comparing, and interpreting multiple pieces of information scientifically. There is another reason trace evidence requires a careful crime scene work. These materials can be extremely small, and because they may be easily transferred, lost, contaminated, or overlooked, investigators need systematic procedures for documentation, collection, packaging, and preservation. The National Institute of Justice emphasizes that physical evidence may not always be visible to the naked eye and can be easily overlooked, making methodical collection and preservation important. Just think about it. If the evidence itself is microscopic, even careless handling can potentially affect the integrity of the examination. So the forensic value of trace evidence doesn't begin in the laboratory, it begins at the crime scene itself. For your UGC NET exam, remember this sequence: contact, transfer, trace, comparison, and association. Someone or something comes into contact, material may be transferred. That material becomes trace evidence. The unknown material can be examined and compared with the known material, and the results may help establish an association. That is the basic logic behind Locard's exchange principle and trace evidence examination. Before we finish, let's quickly revise the points you absolutely need to remember. Point 1. Trace evidence generally involves small quantities of material that can be transferred between people, objects, and environment. Point 2. Edmond Locard is associated with the exchange principle. Point 3. The principle is commonly summarized as every contact leaves a trace. Point 4. The exchange can be mutual. Material may move in both directions. Point 5. Examples of trace evidence include fibers, hair, glass, paint, plastics, soil, botanical material, wood fragments, cosmetics, and other transferred materials. Point 6. Trace evidence can help establish associations between people, objects, and environment. Point 7. Trace evidence does not automatically mean individual identification. Point 8. Interpretation must consider possible transfer mechanisms and alternative explanation. Point 9. Proper collection, preservation, and contamination control are extremely important. And finally, small does not mean that it is not important. Sometimes the smallest clue can help answer one of the biggest questions in a criminal investigation: what happened here? So the next time you hear the phrase trace evidence, don't think of it as just dirt, fibers, tiny fragments, or just microscopic debris. Think of it as a record of contact and movement. A person enters an environment, something may be left behind, something may be picked up, an object touches another object, material may move between them, and those tiny transfers can become scientifically valuable clues. That is the fundamental beauty of Locard's exchange principle. A crime scene may be silent, a suspect may say nothing, a witness may remember incorrectly, but those tiny physical traces can still preserve information about what had happened, And that is why in forensic science, the smallest clue may sometimes tell the biggest story. And that's it for today's UGC Net Forensic Science on trace evidence and Locard's exchange principle. If this video helped you understand the concept beyond simply memorizing a definition, make sure you like this video, share it with your UGC Net preparation aspirants, and subscribe to the channel for more detailed forensic science and criminology concepts, important exam points, and practice questions. And don't forget to comment below. Can you think of one example of trace evidence that could connect a person to a particular environment? Write your answer in the comments. Let's see how many forensic clues you can identify. Until the next class, keep learning, keep questioning, and remember, in forensic science, even the tiniest clue matters a lot. See you in the next video.